Hello everyone, so welcome to my channel. So here today we are going to do the Leetcode bi-weekly challenge as now it's over. So what I'll be doing is I'll make separate video for the same so it would be easily accessible to you all. So now we'll start with the first question. So this question was the easier level question. As you can see in this question itself that the difficulty level is easy. So the main part of the easy level question is something like this, that you can easily go around the question whatsoever is being written there. You could directly do that as it is, because the constraints which are being given to us in the easy level question, they are such a lower constraint that even the brute force which we want to go ahead with, that will also work. So let's go ahead with this particular question. So here you can see that here we are having a question says merge similar items, right? So what the name suggests, that we are required to merge some of the similar items, right? So here you are given with 2D integer array, right? Where item 1 and item 2 are these two arrays which are 2D in nature, and these are representing two set of items. Each array item has following properties. So the properties are like this, that the item of I equals to value and weight, means in these two arrays which are being given to us, here the first one is the value and the second one is the weight corresponding to the same. So where value of I represent the value and the weight of I represent the weight of I's item. So that simply means that in a particular array we are given with value and its weight we are given with, right? So and each of the item which is being present in a particular array, they are unique. So there are no duplicates because they are already merged with each other in a particular array. But here we are required to merge two arrays with the similarity of items. That's the thing. And a particular item consists of one value and its weight. So that is the thing. So now here comes the part, return a 2D integer array where rate of I equals to value and weight of I. That's the thing. With weight being the sum of weights of all the items with value I. So this is the thing which we are required to do here. So here, as the question says, that we are required to merge all the values where we would be having the weights, right? And those weight we are required to sum up, but the weights should be in that manner that the corresponding value to them would be similar. Means what I mean to say is that okay, here I don't have that. Okay, let me just explain you here itself. That the thing here we are given with this, that whatsoever value we are given, so corresponding to that, whatsoever weight we would be having, right? So if there is value, say 1, and its value is 1 itself, but we are having weight, any weight is there, like say it is 2, and there in the second array we are having again the value 1, right? But here the weight is something like this. Here say weight is 5. So our final answer would be something like this. Means in our result, our answer would be value of 1 and its weight would be equal to 5 plus 2, that is 7. So this is the thing which we are required to do in this question. So just first think about the approach, that how we can do this. See, in both here you can see the constraints are much lower. Means the values, what you can say, not just values, but means I'm saying because it might confuse you, but the elements which are being there in this array, they are in such a manner that these are just 1,000 in number. So that's why it is a lower constraint. As I already told you, that here things could be done in such a manner that after adding both of them, we will be easily able to get our answer without optimizing our solution. So now just think about the brute force, that how you will be doing it. So see, here we are given with first array and the second array. Now what we can do is, in C++ or in Java or even in Python, what data structure do you use for keeping the track of the elements in such a manner that we could easily look up into the same? So that data structure is unordered map. But here one more thing is there, that they want these things in ordered manner. See, they have written that return should return in ascending order of value, right? So easily lookup could be done in two ways, in two data structures. One is unordered map and another one is map, right? So here we will be using a map so that it is already sorted inside, right? So that's the thing, we will be using a map. And now what map will do? Map will be easily able to catch up all the items which are present in items 1 array, and then now we are having all the items which are being present in items 1, right? So now the next thing which we are required to do is, now we are required to merge. How we will be merging? We'll check for the items 2, right? And then we'll directly get the elements out of there and check that wherever we were having, like here it is 3 there, right? So we'll check wherever 3 is there earlier, then we'll simply add up the weight of that to this one. This we will be doing by using map. And now comes the next part, that here I was just explaining, so that's why. So I won't show you the whole code now. So here the return type is vector of vector int, right? But we had already stored in a map, right? So now the next part is that as we had already stored in a map, so we can't return that map, right? So what we will be doing is, we'll directly put all the elements from our map to the vector. So this is the thing which we will be doing here, and this is how we can do this question in brute force manner. So now just guess what would be the time complexity and space complexity of the same, right? So as we are using the map, so the time complexity because of that map, and even every time we are just running single loop, right? Not even a nested loop is there. So here the time complexity would be n log n. Log n because the map will have all the sorted order, right? So that's the log n. And the time complexity done. Now the space complexity. So the space complexity would be, at the worst case scenario, we have all the distinct elements and no one adds up to anyone, right? So it would be size of item 1 plus size of item 2. That would be our space complexity at the end. So this was for this particular question. Now we just need to code this. So before coding this, just think about it, how you will be coding up in the interviews. Means after explaining all this to our interviewer, how you will go ahead with the code. So just think about the same, and then I'll show you the code, that how we can do it. Yeah. So yeah, I just recall that from the interviews. So basically, as this panel is being supported by Newton School, so just and somehow a lot of students just ask me about giving them about a course which is well structured and which has the mentorship which is in person to them, means a dedicated mentor is being given to a student. So like that, a particular course and live doubt sessions for them and so on. So for that particular purpose, I would recommend you to check out the Newton School website, and in that you can figure out that what all would you like to go ahead with. So for that purpose, let me show you that how all this would work. But now the thing is that the best thing about the Newton School is that you don't need to pay anything beforehand. Means everything, your fees would be paid to the Newton School would be after your placement only. And they have packages from 7 to 40 lakhs per annum. So I guess it is one of the best things. You can go ahead with the same. If you want to find more details about the same, you could directly check out the link for the same, and that would be in the description. So now comes the part that how we'll code this particular question. So here you can see. So now here the thing is that you will be using a map. Earlier I was using another map. Then I just checked that it is mentioned that it is ascending order. So then I got forward with this map. And then we have taken this array, and this array is basically for storing our answer, because at the end we are required to return vector, right? And now first we are doing this. Why we are doing this? So that we have all the elements in our map itself, and then we are having all the elements in map, then we will be having the weights of the specific element with the same, and then in the next what we are doing is that we are again storing all the elements in our map with corresponding to earlier stored elements. If they are same, then their weights would be added. So that's the thing which we are doing here. And now at the end we are directly pushing our answer towards vector. So this is the thing which we are doing here. And then at the end we are required to return our final array. So this was all for this particular question. If you have any doubt, you could comment that down. I'll sort that in the comment section itself. And this was all for this particular question. So see you in the next video for the next question. Thank you.